Hello, everyone, and welcome to the Future of Rancher Manager and GitOps. My name is William Godfrey, and with me today I have.
Hey, David Stauffer, yes, as well a product manager here at Rancher.
So I'm Senior Product Manager for Rancher Manager, and David covers.
Workload and infrastructure management.
Awesome. So today we're going to be talking to you about GitOps, its role in Rancher, and also some of the future forward things that we have for Rancher.
Okay, so let's talk about Fleet and GitOps, and we're going to show you as well today how you can provision with Cluster API and Fleet's really clusters in a very declarative and scalable, consistent way, which is really key for your platform teams to provide a platform as a service. So when we talk about GitOps, we can really see it's becoming mainstream. We are really talking about early to late majority who starting to adopt GitOps as a safe operating model. Next slide. And as well, what goes hand in hand with this is really the proliferation of clusters. Meanwhile, in the beginning, people often had only one or two clusters. Now, as we can see, most customers and end users have already over 10 clusters, which is really a fleet. And this is why as well, fleet and our GitOps approach is so nice. Next. So GitOps is not your replacement for DevOps. It's not your replacement for platform engineering, and it will not fix your CI/CD problems. I just wanted to have this very early on because sometimes people think GitOps is a solution for everything, and yeah, it's not. So next slide. So what is it really? And it's most importantly a safe operating model. And this why it plays so nice with what we call DevOps. It really reduces your time to market. And how does it do it? Through its safe operational model that you have a ledger of record. It gives you incredible confidence in your deployment pipeline because you know you can always roll back, you have an audit log, you have controls through pull requests, and so on. And this then gives you really accelerates your time to market, which is really important for all stakeholders. It allows you as well to scale significantly with a very small platform team your platform because as we know basically everybody wants platform as a service, but there's only one condition, it needs to be really tailored to them. And the other important bit is it reduces significantly shadow IT and it keeps you consistent, right? Because you can as well, if it goes through Git, you can you have pull request reviews and you have all this great mechanisms we knew as well from code reviews. Next slide. So what is Fleet? It's a GitOps tool, so it keeps in Git all your record ledger, basically what is happening to your cluster. It will continuously reconcile what is happening in Git as your desired state into your clusters. It will integrate in all your in your platform and your different workflows. So it integrates one very deeply into Rancher Manager, and it deeply integrates into your Git tooling, and it deeply integrates as well with other tools like Kubewall. When you think about it, it's really your root of trust, and this is why you need to think about when you do GitOps about some things in a different perspective, because normally it's the first thing you install, and Rancher does the same. It's the first thing that Rancher installs on every cluster it manages, and from there everything goes through Fleet. Next slide. Again, the GitOps principles, these are defined by the GitOps working group and the CNCF, and I think they're quite straightforward. It needs to be declarative. Why is this important? Because we declare our desired state in Git, right? And we need to read from it. Git gives us as well that versioning and this immutable artifacts, right? And the other important bit is that we pull, we don't push. And why does this matter? Because A pull keeps your clusters much more independent. It's much more scalable than a push model. And of course, we continuously reconcile so that we always make sure that the desired state is actually the actual state. Next slide.
So let's talk about Rancher and GitOps in the future. So the future of Rancher. I'd like to begin by taking you through a couple of use cases. The first is Retail Edge. The idea behind Retail Edge is that you have, let's say five platform engineers. They build the Rancher, they build and maintain Rancher and the Kubernetes clusters underneath. They give access to these Kubernetes clusters through projects. So they create a project, and that's the deliverable to their application team. A project is a collection of namespaces. They have the right RBAC inside of it, so that cluster could be split up amongst these application teams. This means that you have about 5 or so platform engineers managing over 200 developers using clusters that are number up to 1,000 regionally. We're talking things like fast food restaurants, things like supermarkets, where each supermarket, each fast food restaurant will have its own stack and its own cluster, and being able to deploy applications across all of them. And that's a huge task for 5 people in one region to take over to handle for 200 developers and 1,000 clusters cross regionally. There's a lot to manage there, and what GitOps really helps you do in this particular scenario is that GitOps allows you to build in that kind of immutability and that trust, as well as that automation, so that you can only affect a single Git repository, and then everything else is automated from that point. Your custom resources that control which keyboarding policies, for example, which OPA policies that you deploy into your clusters to provide those guardrails for those application devs, those get deployed by your GitOps tool of choice. On the other side, we have a very similar but slightly different scenario. We have a financial services company. And in this financial services company, it's much more competitive. Your developers aren't choosing a single platform because that's all the platform they have available to them across all of these thousands of clusters regionally. The choice is made based on sort of compliance and security needs. You'll have competing platforms from Rancher, even to things like OpenShift or Tanzu. And the choice that's made by the developers is which of those platforms best suits their regulatory needs. Maybe the Rancher platform is built to scale vertically. It's much better for hardware accelerated transactions, basically, or higher network bandwidths by using Multis on RQ2. The choice there is really where that limited platform engineering team, which is the same across both of them, they want to make a platform that is as competitive as possible to give their developers the best chance, because they live and die by the sword. If their platform is not competitive and doesn't provide enough value to their developers to meet those needs, the developers aren't going to use them. Which is why we like to talk about innovating everywhere in Rancher. Rancher exists on every single level, whether you're on-prem using bare metal, Harvester or vSphere infrastructure providers, or you're using RQ1 K3S or bringing your own clusters on-prem. Even in the cloud, where you're allowed to register clusters like EKS, AKS, and GKE across AWS, Azure, and GCP. Even when we look at the edge, if you've looked at any of the edge presentations during SUSECon, you'll see that there's a lot of talk around near edge, far edge. You've got the telco industries. Rancher exists across everywhere and innovates everywhere. We give you the toolbox to build the best platform for your scenario and make your platform as competitive as possible for your devs, and to give you the freedom and flexibility to have a limited resourced platform engineering team work for 200 developers across 1,000 clusters. And this is what Rancher brings to you today. Today, we have cluster provisioning. Today, we have authentication and RBAC, being able to configure and assign permission through projects to your auth provider, through your enterprise auth provider, that is. Application deployment, being able to deploy and operate on applications running in Kubernetes, giving your developers access to do it themselves, so that your platform team don't need to have the knowledge necessary to operate on the applications themselves. The dev teams can troubleshoot and test and build things without any of that help needed. And monitoring and logging, being able to track your sort of mission critical information and gain insights on how your platform is operating, being able to build it towards the future to make it more scalable, make it more resilient, and make it more reliable. Rancher provides all of those today, but I'd like to focus in on one topic in particular, and that is cluster provisioning, creating, updating, and deleting Kubernetes clusters. In Rancher today, we have two provisioning mechanisms, what we call provisioning v1 and provisioning v2. These are automatic provisioning mechanisms. What they do is you'll use something called a node driver, which is based on a technology called Docker Machine. And Docker Machine interacts with an upstream cloud provider, let's say AWS or Azure or vSphere. Docker Machine will interact them through the node drivers, and it will bootstrap onto it something like an ArcE2 cluster or K3s cluster. In provisioning v1, you only have the node drivers. In provisioning v2, we use a mix of two different things. We use a very opinionated implementation of CAPI. CAPI is known as Cluster API, is an upstream project, which we'll talk about more in detail. But we have a very opinionated and very slimmed down version of CAPI embedded in Rancher today. What happens in provisioning v2 is the similar sort of setup where CAPI is used to define what a cluster is, but then Docker Machine and Rancher custom resources take over afterwards. So where is this going towards? Well, I'd like to introduce you, like I've just mentioned, Cluster API. Cluster API is an upstream Kubernetes project. It's designed to standardize cluster creation and lifecycle. So what does it do? Well, the way that Cluster API works is there is a core CAPI controller. This is what's embedded in Rancher today. And it has a standard cluster definition. It creates a custom resource that describes a cluster. This is standardized upstream. This is used by various different vendors. And this standard cluster definition can then link into two extra concepts, something called an infrastructure provider. An infrastructure provider is an external installable provider that acts as an API client for your particular infrastructure. For example, AWS, it will interact with AWS Kappa or Kappa to create VMs, it creates the networks, the VPCs, etc., and it will act as the infrastructure API client there. Then you have something called a bootstrap provider, which is specific to that Kubernetes distro, and it will actually provision those Kubernetes distro on the nodes on there. So within Rancher today, we don't use this fully. We have the ability, we have the core CAPI controller, but you can't install an infrastructure provider or bootstrap provider of your own choice. You have to use our node driver system on top. And what we're getting to is why why didn't we give you the ability to install those extra things on top? And the reason is that Cluster API doesn't bring full cluster lifecycle management in the way that Rancher defines it. Rancher has a very precise definition of full cluster lifecycle management. We include all of the things like data operations. So we're talking cluster upgrades, we're talking certificate rotations, and we're talking things like cluster restores and cluster backups. Everything that our customers have expected from us, Cluster API today doesn't do, which is why we kind of went for this half and half scenario, where we have bits of Cluster API as a definition, but we still rely on the node drivers to deliver those day two operations. So where are we going with Cluster API and Rancher in the future? Well, what we're quite excited to talk to you about today, and we're in the very early stages of this. So there's nothing available in Rancher today. We have bits of Cluster API, but they're still embedded inside of Rancher and not usable for customers. But we are looking to increasingly build Rancher around open standards and not specific integrations like we have with the Docker Machine node drivers and the node drivers that we maintain ourselves today. So we're currently investigating how Rancher can leverage Cluster API fully. And to that extent, I'd like to show you a demo of where that investigation has taken us so far. So let me get that up, wherever it's gone. Here we go. I need to share my screen, I believe.
Okay, so what you see here is basically the workflow, how you would use our Cluster API extensions that we are building experimentally together with Fleet as a GitOps tool to basically use the GitOps methodology to provision clusters in a very scalable and consistent way. So what we see here on our side is our repository where we have our cluster definitions. Continue. And here we see basically the Fleet YAML, which basically instructs our resource reconciler with Fleet to get the definitions into our management cluster, where the CAPI controllers are. Here you see basically an example of a cluster API definition, and just to highlight, you can as well template them out and render them automatically. So there is already basic templating in Cluster API, and Cluster class is experimental, which will allow you to have a single template and many clusters that are stemmed out of this. Then as a next step, what we're going to do is we're going to add this repository to our GitOps engine, which is in this case Fleet. And we're going to even use for this our great UI that we have. So as you can see, you add here your Git repository. We select the branch, and this will create a Git repository resource and start to reconcile it. And as you could see, we already had the cluster definitions, and they now get automatically applied by Fleet. And what you have not seen is, and because we didn't show it, but we already have the cluster API controllers running in the Rancher management cluster. This means this will get picked up and now start to provision a new cluster. And this is what we see on the right-hand side is how the cluster API controller picks it up and starts to provision this new cluster, which we will then directly import back into Rancher Manager so that you have a frictionless experience just as you are used to, and basically getting them from there on just to use the workflows you're used to do with Rancher. So this is basically, I think, it. We are just waiting that the cluster gets the ready state. We deploy now the fleet agent and everything. And from here on, you can imagine how you do everything else, right? You could have your whole loadout for your cluster, all your cluster components directly applied by Fleet to this kind of cluster class if you wanted. And how would you define it? With a label. And that's basically it. This is the demo.
Awesome. So just to summarize there, as you just saw, using Fleet with its GitOps capabilities of being able to watch watch resources in a Git repository, having that automatically reconciled down to your local cluster, Rancher picks that up, Rancher then operates on it, and then provisions a cluster for you using that. Again, this capability is still far out. We're still in the early stages of investigation, but we're very much looking forward to bringing more of this capability as we progress along, using CAPI natively within Rancher and bringing CAPI within Rancher in the future. But the real goal for us here in the future of Rancher in general is leveraging things like GitOps with custom resources to make Rancher a declarative interface for customers, whether it's cluster lifecycle using Rancher provisioning or cluster API as they are today, security using new vector and keyboarding network and emission controls, deploying down your keyboarding policies and your new vector network policies, or whether it's just basic GitOps and doing application delivery, being able to deploy your applications into a cluster automatically, or even observability, being able to automatically pick up and respond to observability changes within Rancher, having predefined alerts that you can add into your cluster using GitOps and having that fall through. What we're really looking towards Rancher being in the future is the core of your platform, the platform that you are building. Rancher is providing the correct tools to build it as flexibly and as easily as you need to, without hemming you in and putting you into an incredibly opinionated build. So using Rancher to provision clusters and being able to use GitOps to drive that is where we're going in the future. So where are we going next, David?
Yes, sorry. Where we go next, so we want to enable the whole journey, which means as well the cluster provisioning with GitOps methodologies. So this is the next step. We want to enforce more and more that you really can use Fleet as your root of trust in your supply chain. And we want to leverage this and start the orchestration of workflows in your supply chain using events. That's it.
Thank you for listening. And yeah, thank you.